Welcome back, students. This is the session 1 of the JEE Advanced playlist. The chapter is Units and Measurement, and this is the question which I have taken for this session. This question was asked in the JEE Advanced paper in 2020, and the Units and Measurement chapter is the first chapter from the syllabus of class 11. So, here the question here is, sometimes it is convenient to construct a system of units so that all quantities can be expressed in terms of only one physical quantity. So here it is written that in one system of unit, the dimension of different quantities are given in terms of a quantity x as the dimension of position is given by x to the power alpha, dimension of speed is given as x to the power beta, dimension of acceleration is given as x to the power p. The dimension of linear momentum is given by x to the power q, and the dimension of force is is given by x to the power r. Now we know that the dimension of the position um, dimension of the position is given by L to the power 1. Similarly, the dimension of speed is equal to distance upon time. The dimension of distance is L1, so this will be equal to L1 t minus 1. Now the dimension of speed and this acceleration is acceleration is equal to velocity upon time. So the dimension of velocity, that is velocity upon time, and velocity is equal to distance, that is equal to displacement upon time. So what is acceleration is equal to velocity upon time, velocity is equal to displacement upon time, so this will be equal to t, and the dimension of this displacement is L, and here in the dimension of time is t, so this will be t square. So the dimension of acceleration will be equal to L1 t minus 2. So this is how we find the dimensions of the different physical quantities. Now similarly, the dimension of linear momentum will be this will be equal to x to the power, this will be equal to momentum is equal to mass into velocity, so this will be equal to m1, and we have already calculated the velocity of this speed. So the dimension of speed of velocity is L1 t minus 1, L1 t minus 1. So dimension of linear momentum is written here. The dimension of force, is equal to mass into acceleration. So the dimension of mass is equal to m1, and force, that is acceleration is L1 t minus 2. So these are the dimensions of force, linear momentum, acceleration, speed, and position in the SI system of units. Now here it is written that these quantities are expressed in terms of another quantity x as written on this board. So as per the principle of homogeneity, now in the topic of dimensional analysis, in the chapter of units and measurement, there is a principle called by the name of principle of homogeneity. It states that an equation is correct and homogeneous if the dimension of all the terms on the left hand side of the equation is equal to the dimension of all the terms on the right hand side of the equation. So I will be using this concept in order to solve this question. So first thing is that I will be writing all these dimensions here on the top in order to because I will have to rub this board here and proceed further. So the dimension of position is L1. The dimension of speed is given here as L t minus 1. The dimension of acceleration is L1 t minus 2. Okay. So now what I will be doing here is the dimension of position is L1. So L1 should be equal to the dimension of position here is x to the power alpha. So this is the first equation I am getting. Second, the dimension of the speed is L1 t minus 1, and this should be equal to x to the power beta. So this is the second question, this second equation. Third, the dimension here this dimension of linear momentum and force, I am writing it here. That is the dimension of force is equal to m1 L1 t minus 2, and the dimension of linear momentum is m1 L1 t minus 1. Okay. Now the third equation, the dimension of the speed acceleration, this is L1 t minus 2. This should be equal to x to the power p. So this is the third equation. Fourth equation, linear momentum. The dimension of linear momentum is m1 L1 t to the power minus 1. This should be equal to x to the power q. So this is the fourth equation. Then force. The dimension of force is m1 L1 t minus 2. This is equal to x to the power r. So this is the fifth equation which I have got. So these are the 5 equations which you have got, and out of these 5 equations we have to derive, we have to find a relation between P, Q, R and this alpha and beta. So here first of all you just what I will be doing is just see from this equation 1 and 2. If I divide the equation 2 by 1, if I divide this equation 2 by 1, what I will be getting? If I divide this equation 2 by 1, I will be getting, or if I divide this equation 1 by 2, what I will be getting is that this L1 divided by L1 t to the power minus 1, this will be equal to x to the power alpha divided by x to the power beta. So from here on the left hand side, this L1 and L1 will get cancelled out. So t to the power 1 will be equal to x to the power alpha minus beta. So this is the first relation, x to the power alpha minus beta. Okay. So here I will be writing this value here now. So from equation 2 and 1, that is by dividing this equation 1 by equation number 1 by 2, I have got this relation, that is t to the power, this 1 is equal to x to the power alpha minus beta. So I am writing it here now. T to the power 1 is equal to x to the power alpha minus beta. This is the first equation which I have got. Now, from this equation 2 and 3, If I divide this equation 2 by 3, then I will be getting if I divide this equation 2 by 3, then I will be getting t to the power 1. This will be equal to, I am dividing this equation 2 by 3, so I will be getting x to the power beta minus p. So I have got another equation, that is t to the power 1 is equal to x to the power beta minus p. Okay, this is the second equation which I have got. Now, from these two equations, I can write that x to the power alpha minus beta is equal to x to the power beta minus p. Or it implies that alpha minus beta is equal to beta minus p, or it implies that alpha plus p is equal to 2 beta. So I got the first relation as alpha plus p is equal to 2 beta. So alpha plus p is equal to 2 beta. This is the first. So this option A is correct. Okay, so I will be writing this alpha plus p is equal to 2 beta. So this is what I have got. So I will be writing this somewhere here now. That is alpha plus p is equal to 2 beta. Okay, so this is one option which we have, or you can say this is one relation which we have got from equation number 1 by considering in the first case I have considered the equation number 1 and 2, and in the second case I have taken the equation number 2 and 3. Okay, so I have got this relation that alpha plus p is equal to 2 beta, so option A is correct. Now we have to find whether any one of the remaining 3 options is correct or not. So now see this equation here, second equation and the fourth equation. So if I divide the equation number 4, if I divide this equation number 4 by equation number 2, what I will be getting is, that is, I am dividing equation number 4, that is m1 L1 t minus 1 m1 L1 t minus 1 is upon L1 t minus 1. That is, I have divided this equation number 4 by equation number 2. So this will be equal to x to the power q divided by x to the power beta. So from here it implies that m to the power 1 is equal to x to the power q minus beta. Now take this relation, that is 3 and 5. So if I divide this equation 5 by 3, what I will be getting? That is m1 L1 t minus 2 divided by 3, that is L1 t minus 2, this is equal to x to the power r divided by this is x to the power p. So from here what I will be getting is, that is m1, this is equal to x to the power r minus p. Okay, so from this equation now I got two equations, that is m to the power 1 is equal to x to the power q minus b, and there's one more, that is m to the power 1 is equal to x to the power r minus b. So it implies that from these two equations, that is x to the power q minus b, this is equal to x to the power r minus b. Okay. So so if I solve this equation, that is x to the power q minus b is equal to x to the power r minus b. So from this equation, I will be getting q minus beta is equal to r minus p, or it implies that q plus p minus r is equal to beta. This beta has been taken on the right side of this equation, and r and p, that is r and this term, that is the term on the right side of the equation, has been taken on the left side of the equation, and beta has been taken on the right side of this equation. So what I am getting is q, this is minus p, so this will become plus p, q plus p, and this is plus r, so this will become minus r. So q plus p minus r, and beta will go on the right side of this equation, so this will be equal to beta. So I am getting another relation, that is q plus p minus r is equal to beta. So this is a second relation. So so now q plus p minus r, this is q plus p minus r is equal to beta, is equal to, so this option is, A option is also correct and B option is also correct. So so in this question, as you can see that there are two options which are correct, and the most important thing which we have to remember in this question is that we have to use the principle of homogeneity. So thank you very much for joining this session, and in the next session I will be coming up with some other question from the JEE Advanced, and it will be pertaining to this chapter only. So till then, have a nice day. Bye.